Just released, Elon Musk unveils a new insane engine. One of the most essential inventions ever devised by man is the electric motor. From physically changing the way we think about the world to paving the way for the future. Things are about to get much more interesting now that Elon Musk has revealed Tesla's amazing new motor. It'll blow your mind how it works. Welcome to Tech Sector. Don't forget to subscribe to our channel and hit that bell icon, since we're your go-to source for all things Elon Musk, Tesla, and SpaceX. Let's take a closer look at the building of a Tesla electric drivetrain, which Nikola Tesla created over a century ago. The stator and rotor are the first two important components to consider.
The rotor is basically a collection of short-circuited conducting bars linked by end rings. The stator is powered by a three-phase AC power supply. A magnetic field is created by the three-phase AC in the coils. A four-pole magnetic field is produced by Tesla motors. The rotor bars are turned by a current generated by the rotating magnetic field. The rotor speed, RMF speed, of an induction motor frequently lags behind the rotor speed. An induction motor is quite powerful despite the lack of brushes and a permanent magnet. Induction motors are unique in that their rotational speed is determined by the frequency of the AC power source. This means that the frequency of the power source can be changed to change the spinning speed of the wheel. Tesla's speed control is incredibly simple and reliable. Tesla motors have a range of rotational speeds from 0 to 18,000 revolutions per minute, RPM. The induction motor receives power from the battery pack. Because the source generates DC power, it must be converted to AC power before it can reach the motor. This is when the inverter enters the picture. Not only does the inversion convert DC to AC, but it also adjusts the frequency of the AC power, allowing the motor speed to be controlled. The inverter may change the motor output power by changing the amplitude of the AC motor. In a sense, the inverter is the brain of the electric vehicle. The battery packs are made up of massive collections of regular lithium-ion battery cells similar to those seen in everyday life, which most people are surprised to discover. To produce the required electricity to run the electric car, all of these cells are connected in a series and parallel fashion. Glycol coolant is circulated between the cells through intertwined iron inner tubes. This is one of the concepts that distinguishes Tesla from other electric vehicle manufacturers. Instead of a few large cells, multiple small ones are used to provide critical cooling. As a result, thermal hotspots are reduced, resulting in a more even temperature distribution across several cells and longer battery pack life. All of these cells are organized into detachable modules, totaling around 7,000 cells divided into 16 modules. The Tesla Model S Plaid is currently the best display of Tesla's engineering prowess, at least until the Roadster arrives. Teslas have always been fast, and the firm, led by its nerd-in-chief, looks to be nearly as capable of pushing inside joke limits as it is of achieving significant, industry-shifting advancements. It is entirely successful in driving Tesla's performance to ludicrous new heights. It's the first Tesla to use 3 electric motors, 2 in the rear axle and 1 in the front axle, all of which are now permanent magnet synchronous AC machines. The Plaid features carbon fiber sleeved rotors, the spinning component of the engine. A carbon fiber cover holds each rotor together, enabling for rotational rates of up to 20,000 RPM, which is roughly 25% quicker than before. Because of the differing coefficients of thermal expansion between carbon and copper, Tesla asserts that the motor's copper wire must be coiled at extremely high tension, resulting in a particularly efficient electromagnetic field. Furthermore, the Plaid avoids a common EV problem, particularly in cars with a direct drive transmission, such as Tesla's, where power declines dramatically as speed increases. The Tesla Plaid maintains 1,000 of its 1020 horsepower, all the way to its top speed of 200 miles per hour, according to Tesla. Despite having more horsepower, the Plaid weighed 175 pounds, less than the Model S Performance variant, which weighed 4,828 pounds. So, how does the vehicle fare? Motor Trend reports that at 152.6 miles per hour, the Model S Plaid completes the quarter mile in a remarkable 9.25 seconds. After a brutally forceful launch, the car accelerates from 0 to 60 miles per hour in under 1.98 seconds. The Plaid travels so quickly that it's tough to keep track of what's going on. As a quarter mile of pavement melts beneath you, the yoke becomes light in your hands, your neck muscles strain as your helmeted head digs into the headrest, and your surrounds blur into simple forms and colors. Despite the fact that the automobile cannot attain and sustain 200 miles per hour at this time due to the risk of damage to the powertrain, this is a significant achievement. Tesla intends to improve top speed restrictions for the next Roadster, which is expected to represent the next paradigm shift in EV performance technology. With such significant advancements in automotive battery technology, Tesla has made the decision to convert to lithium iron phosphate batteries. Tesla's decision is most likely a way to increase profit margins on its fully electric automobiles without having to raise prices. Tesla has already been lambasted for its unpredictable automobile pricing. The company is already producing autos with LFP chemistry at its Shanghai factory. It sells the automobiles throughout China, the Asia-Pacific area, and Europe, among other places. According to materials researcher and consultant Roskill, China pushes the use of this type of battery, and roughly 95% of LFP cathode production is supposedly done in China. In September 2021, Tesla asked Model 3 reservation holders in the United States if they would accept a car using LFP cells instead of the nickel cobalt aluminum oxide (NCA) cells used in previous Model 3 sedans shipped in North America. In addition, they are continuing their research and development of the new 4680 battery cells. The 4680 designator refers to the battery's diameter and height, which are 46 mm and 80 mm, respectively. With fewer cells needed to generate a full-size pack, this relatively large size, combined with promises of greater power density, is predicted to save costs by up to 14%. A schedule for mass production has yet to be established. Panasonic, on the other hand, told US media after announcing its financial results for 2021 that it will prioritize Tesla car supply while also speaking with other manufacturers. While the new technology has been hailed as a big step forward in lowering the cost of entry for environmentally friendly vehicles, Tesla recently stated that plans to manufacture a more affordable hatchback called the Model 2 have been put on hold for the time being. To save money and improve efficiency, 4680 batteries can still be put in current Model 3 sedans, Model S sedans, Model Y SUVs, and Model X SUVs. Electric vehicles are reshaping the hypercar and racing performance environments. These new hypercars have pushed the engineering envelope to the point where, metaphorically speaking, internal combustion engines have run out of steam. Consider the Hennessy Venom F5 and the Bugatti Chiron, which are both capable of reaching top speeds without the use of electric propulsion. Combustion engines required about 150 years to acquire this levels of performance. All-electric hypercars, like the Lotus Evija and the Rimac Nevera, have been constructed in recent years, and they easily outperform the Venom and Chiron in terms of power. It was the first-generation Tesla Roadster, crucially, that paved the ground for it to happen, and now Tesla must take the next significant step ahead to compete with their new rivals. The Tesla Roadster, which has been frequently delayed, received a rare update from Tesla chief designer Franz von Holzhausen. According to the designer, Tesla is still nervously working on the electric hypercar, which will be an exciting flying machine. According to Musk, Tesla intends to sell a SpaceX package that includes cold air thrusters all around the car to boost performance. According to him, the kit may reduce the time from 0 to 60 miles per hour to 1.1 seconds. Can you believe it? That will be the fastest car ever built, and only a select few will be able to beat it in a reasonable amount of time if they can. We hadn't heard anything about the new Tesla Roadster in over a year, so we believed it had been delayed again. The manufacturer has had a difficult year due to chip scarcity, and the Cybertruck, which is clearly a priority, has been delayed as well. When asked about the Roadster's schedule in September 2021, Musk indicated it has been postponed until at least 2023. Furthermore, the CEO noted that its arrival in 2022 will be dependent on how much drama Tesla experiences. Let's cross our fingers and hope for the best.